In the last video we talked about increasing functions and decreasing functions and what they mean for the gradient. So let's start with a little example. If we've got a curve like this, kind of looks a bit like a quadratic, but if you've done some statistics it should look like a normal distribution. You can see that on this side here it's going downhill, and we discussed last time that that's called decreasing, and that happens when dy by dx is less than 0. On the other side we can see that it's going uphill, and that happens when dy by dx is bigger than 0. Now it follows that in the middle of there we have something called a stationary point, and that is when dy by dx is equal to 0. So the tangent at that point is actually a horizontal line. So we're going to look at those in a little bit more detail, these stationary points. I've written at the top there 3 things that mean exactly the same thing. The word stationary point means the same as dy by dx is equal to 0, and of course sometimes we might see it with function notation, f dash x equals 0. We're going to break those down now into some more specific cases, and you really need to understand all these different ways of describing these points. So under stationary point we can have 2 options. One's called turning points, we'll come to them in a minute, and one's called point of inflection, or points of inflection. So turning points are things that you're already familiar with. We could have a maximum turning point or a minimum. Maximum look like upside down quadratics. It's got a maximum point at the top there, which I'll draw in green, and a minimum similarly has a minimum point. Of course some functions like cubics might have a maximum and a minimum point, if you remember the shape of a cubic. It turns out as well that we can test a point to see whether it's a maximum or a minimum by using the second derivative, and we'll come to this in a future video. However, just to make you aware of it now, if we take the second derivative, so we differentiate again, and it is less than 0, that's a maximum point, and if we take the second derivative and it is bigger than 0, then it's a minimum point. So turning points is a special type of stationary point, and that breaks down further into maximum and minimum points. Points of inflection are slightly different in that whereas a maximum point, if we look here on the maximum point diagram, it goes positive, then goes to 0, and then changes to negative, and a minimum point starts off negative, changes, and then goes positive. The points of inflection, like you've seen on a cubic graph, they look like they're going to change. So they start off positive, for example, they look like they're going to change to negative, but in fact go 0 and then carry on positive again. So the gradient is positive here and it's positive here. So point of inflection does have 0 gradient, but it doesn't actually change from positive to negative or negative to positive. Make sure you can recreate that diagram, and therefore you understand what the question is asking you to do.